Welcome everyone. Today we're going to break down the inner workings of a Python-based point-of-sale, or POS, system designed specifically for a coffee shop. Let's start by looking at how the system is structured. Everything is driven by a core class called POS system. Right at the top, it defines a class variable called item_ID, which stores 5 unique product IDs for our coffee menu. When you initialize this class, the constructor takes those IDs and uses them to set up a self.inventory dictionary. Each product ID maps to an object containing 3 crucial pieces of data: the item's name, its price, and how many are left in stock. Finally, the constructor sets up an empty self.cart dictionary to keep track of whatever our customers decide to buy during their session.
Now, before a customer can buy anything, they need to see what's cooking. That's where the display_menu method comes in. It simply loops through the inventory dictionary and prints out a clean formatted menu showing the item ID, the name, the price, neatly rounded to 2 decimal places, and the current stock availability. But things get really interesting when a customer tries to add an item to their cart using the add_to_cart method. This method acts as a strict gatekeeper. It performs 2 critical validations. First, it checks if the requested item ID even exists in our inventory. If it doesn't, the request is instantly rejected. Second, it checks if there's enough stock. If a customer asks for 5 lattes but we only have 2 left, the system catches it and lets them know the actual limit. If both checks pass, it uses a safe dictionary.get method to update the cart, increments the item count, and immediately decrements that same amount from the inventory to keep everything synchronized.
Once the user is done shopping, they head over to the checkout method. This is where the final receipt is generated. The system starts with a quick guardrail. If the cart is empty, it stops you right there. If there are items, it loops through your cart, multiplies the quantities by the individual prices, and sums everything up into a subtotal. Then it calculates the tax. By default, it applies a standard 12% tax rate, though this can be adjusted via parameters. It then prints out a beautiful formatted final receipt. Now, here is a quick gotcha for developers looking at this code. The checkout method doesn't automatically wipe the cart after printing the receipt. In a real-world scenario, you'd want to reset that cart so the next customer doesn't accidentally inherit the previous person's order. Finally, how does the user actually interact with all of this? The script kicks off by instantiating the POS system object and dropping the user straight into an infinite loop. This loop constantly refreshes and displays the menu, then prompts the user to enter an action code: 1 to add items, 2 to check out, or 3 to exit. It's a clean, straightforward workflow, though it is worth noting that the current setup doesn't allow users to view their cart before checking out, or remove an item if they change their mind. Hitting 3 breaks the loop cleanly, shutting down the application. And that is a high-level look at our coffee shop POS system, built on smart validation,